ALS is a progressive nervous system disease that affects nerve cells in the brain and spinal cord, causing loss of muscle control. An ALS patient may rely on mouth movements for communication, calling for highly accurate lip reading models. Existing lip reading models do not directly adapt on such patients as they have peculiar lip movements and vocabulary. Collecting data for building deep learning models can be mentally and physically taxing for such patients. In this work, we propose personalized one-shot lip reading for an ALS patient. We first demo the website that is being used by the ALS patient. The website is highly accessible and can be accessed through a computer or even a smartphone device. The patient is first recorded, currently with an external help. Once recorded, our model infers in the backend and displays the top 5 inferred results. The helper can then assign the correct label. This helps us in data collection that can be used for improving the model further. The helper can also cancel or discard a recording by clicking on cancel. We show our results on 4 more speakers. 3 speakers with hearing impairment, and Joe Biden as a regular speaker. We will now explain our proposed pipeline and architecture. With just one-shot examples, we employ data augmentation and domain adaptation scheme to train a robust model that can work accurately on a patient. First, we curate the vocabulary for a speaker which is important for them in their daily lives, for example, backache, nauseous, etc. Second, we collect unlabeled videos which can be easily collected without any manual intervention. We use wave-to-lip, a lip-sync model, for data augmentation. Wave-to-lip modifies the mouth movement of a face video according to a guiding speech utterance. Variational encoder is then used for domain adaptation and training a robust lip reading model. It is made of 2 encoders, source and target encoder. The source encoder is given the combined data as input, and the target encoder sees the one-shot real examples as input. The target encoder learns to generate a latent distribution of the class of mouth movements. A random point is then sampled from this latent distribution that acts as a variation of the real domain. The source encoder learns to generate domain invariant features by reducing the feature distance between the synthetic and the randomly sampled real representations. The classifier learns to classify while helping both the encoders to generate task-relevant latent distribution. This eliminates the need for non-trivial input reconstruction as required by variational autoencoders. Together, the different components help in domain adaptation with just one-shot example using the simple classification laws. Now, we will show some examples and comparisons. We show our comparisons with 2 other models. The first is a baseline model, which is a simple classification model trained on one-shot examples. The second is a classification model trained on the combined data of one-shot and synthetic examples. The third is a proposed model. The green boxes indicate that the correct prediction was in the top 5 predictions made by the model. The red boxes indicate otherwise and displays the rank predicted by the model of the ground truth. Some failure cases. All the models fail to generate correct predictions at top 5. This could be related to the lips being occluded by the hands of the deaf speakers. Some more examples. In summary, we propose a novel architecture, variational encoders for lip reading with one-shot examples. Synthetic data is used to augment the one-shot examples, and variational encoders are used to domain adapt while generating more variations for our real domain. Our method can also be extended to other problem statements with one-shot examples. Thank you for your time.